So thank you very much. Thank you for the invitation. Also thank you for the kind introduction. What I would like to show you now is, sorry, as long as my voice lets me. What I'm showing you now is a potential path towards Sustainable Development Goal 7. That is dealing with clean and affordable energy. And we all know that we have targets, we have indicators, and the story behind it is rather simple. It is that we should save energy, we should be more energy efficient, we should turn to renewable energies, and that we should have also global partnerships on research and investments and so on in this field. As is also shown on this slide, it's the same story about what is SDG 7. And the question is now, how do we do that? And we have different approaches to that. We have different disciplines bringing in their different knowledge bases. And what we were looking at this issue is, what could you contribute as a spatial planner, as an urban and regional planner, who is working on the question of how infrastructures, houses, companies, and so on should be distributed in space, and where to find the ideal locations for different issues. What I would like to show you now is the approach, the general approach to integrated spatial and energy planning, as we have drafted it, and mainly at our institute, also in governmental working groups, and this is also an issue where we have now also governmental decisions on it. And the main thing about integrated spatial and energy planning is that there is a recognition that spatial development has something to do with energy consumption. It's very plain, very simple, but there are dimensions of the energy demand, spatial dimensions of energy demand, and there are spatial dimensions of energy supply, and we have to consider them in drafting our spatial plans, not only spatial policies, but also the spatial plans on the provincial, the regional, and the local level. We have, of course, written books on it, and the yellow thing here is very interesting. It's a paper series by the Austrian Conference on Spatial Planning. That is a body, it's an organization that coordinates spatial planning activities between the federal state, the province, the state, the federal states, and municipalities, cities, and so on in Austria. And I was accompanying, scientifically consulting a working group that defined the idea of integrated spatial and energy planning as part of spatial planning. So what are the spatial dimensions now? In the energy supply, and when we look at the energy demand, there is something like energy efficiency of spatial structures as a refrigerator or whatever would also have a kind of energy efficiency based on the components the technical device has. And then the same thinking, we are approaching spatial structures that have components like, for instance, residential areas, commercial areas, industrial areas, and so on. What is an energy efficient spatial structure? It's one, and for spatial planners, this is a very familiar terminology. It's mixed-use areas, it's something that deals with density or moderate density, depending on the spatial archetype you are in. If you are in an urban area, a rural area, of course, you have a different perception of density. It's about compactness of settlement structures, of nearness, so that you can maybe also have walkable and bikeable settlement structures. This is very important, and that saves energy. This is nothing new, of course. That's something we already know for 40 years. Much in the sustainability debate is known for 30, 40 years, but it's still not put into operation. And this is the problem, not to know these issues, but to put them into operation. And that's what I'm talking about. And then we have a spatial dimension of the energy supply. And this has to do with the securing of sites for all kinds of energy facilities, a power plant, a cable line, whatever needs locations, needs sites, and you have to secure them. It's about the securing of resources. And I would say this is a rather new idea of the energy turn and the energy transition. What does it do in space? Because what we are now doing, if you talk in an ecological footprint language, most of our energy supply is based on borrowed land from the past. That means fossil energy that was transferred, or biological productive land that was transferred into fossil energy under conditions that are no longer available in this planet. And now we are able to dig this out, use this resource. But if we take the energy transition serious, we have to stop using this resource, which means we are no longer able to borrow land from the past. We have to integrate it in the present land uses and land use matrices. And this is something that is actually new in the energy transition. And then, of course, this will cause land use conflicts, and we have to deal with them, and we have to mitigate them. And finally, we have found out that these efficient or energy efficient spatial structures are not only energy efficient, but it's easier and more economically feasible and technically feasible to have grid-bound energy supplies in these kind of energy efficient spatial structures. So what we are targeting also with the ideas to implement this issue in spatial planning in Austria is to deal at the moment mainly with these energy efficient spatial structures. Of course, we know that we have to take care of where the renewable energy is produced, take care of wind power plant sites, and so on and so on. But this is a very important also issue to combine the spatial dimensions of the energy demand and the energy supply. And this is also, by the way, these are the places where the people live. And this is also very important. And of course, just want to show that with this slide that shows urban areas, small towns and rural areas in Austria. It's very clear that in these spatial archetypes we have very different possibilities and potentials to design the energy transition. Urban areas, when you look at what is energy efficient, compactness, mix of functions, density, nearness, and so on, these are mainly assets of urban areas. So we have huge energy efficiency potentials there, but a limited potential to produce renewable resources there. That's the one thing. In the rural areas, we may not have that much energy efficiency potentials and gains in energy savings, but we will have the renewable we have the renewable resource base there. And so that means that we have to define certain interlinkages between urban areas, rural areas, suburban areas, and so on. And we have to make use of the conditions in these areas in order to design the energy transition. And what we are doing, and this is now an example, in the province of Styria, so maybe some of you have been or know Graz. Graz is the provincial capital of Styria. Is one of the major provinces in Austria when it comes to area, size of in square kilometers, if you want, and also, yeah, about 20% of the Austrian population might live there, a bit less maybe. And it consists of 287 municipalities. If we look at the map before, it would be somewhere around here. And this is Graz. So this is where I'm talking about now. And what is the idea behind the program that the province of Styria has now developed, and we have actually advised them and consulted them in doing so from a science base, is that they wanted to roll out a program of integrated spatial and energy planning for the whole province, for all municipalities, and they we combined different issues together and developed that and combined it. The one thing is the creation of a database. We have heard a lot about data now. If you want to make a consistent policy in a certain area, you need a consistent database. That's the first thing. Then I would like to show you, and I will show you a bit of the methodology behind it now, about priority areas for district heating, for grid-bound energy supplies, district heating, cooling, and so on. We will come to that later, why this is important in the energy transition. And we wanted to think about priority areas for energy saving and also for energy saving and environmentally friendly mobility, which is also healthy because it's mobility that you can cover on bike, walking, and also you combining that with public transport. And this is all possible in this energy efficient spatial structures I've shown you before. So the spatial structures that are based on mix of function, moderate or appropriate density for a spatial archetype, and nearness, compactness, and so on.